Welcome to the second lesson of the rate and extent of chemical change topic. In this topic, the key question is 1. What are collision theory and activation energy? Key terms that you need to be familiar with: collision theory, activation energy. In today's lesson, we will talk about collision theory and activation energy. Let's start to talk about collisions. Collisions happen when two objects physically interact. Collisions can be elastic or inelastic. Elastic collision happens when no energy is exchanged between the colliding objects. And inelastic collision is when energy is transferred from one object to the other. The same happens with particles. Particles, atoms and molecules, move constantly. Via their constant movement, they collide. Via these collisions, they exchange energy. Task. Now please pause the video and think about why collisions are important for a chemical reaction to happen. Hint: in a chemical reaction, the electronic structures are disturbed. Extension: how can you describe chemical reactions with collisions and electrons? In order to observe a chemical reaction, molecules have to collide, which means that they need to get into physical contact. If we consider a simple reaction between hydrogen and oxygen, 2H2 plus O2 goes to 2H2O. In the first place, hydrogen and oxygen molecules need to meet. In the second step, the bond between hydrogen atoms within the hydrogen molecule needs to be broken. This requires energy. This energy can be provided by an energetic enough collision. However, most collisions do not provide enough energy and therefore will not make the H to H bond break. The smaller the kinetic energy of the colliding molecules, the smaller chance you have for a reaction to happen. If the collision provides enough energy to break the H-H bond, then the energetic H atom will need to collide with an O2 molecule in order to form new OH bonds and to form water. In any reaction, electronic configurations are rearranged. Old bonds break and new bonds are formed. Task. Now please pause the video and try to think about the energetics required to break and form bonds. Hint: in the first step, old bonds are broken and new bonds are formed in the second step. Extension. How could you represent it in an energy diagram? As mentioned above, collisions should be energetic enough to be able to break old bonds. Once old bonds are broken, then usually energetic atoms or radicals, particles with unpaired electrons, are formed that will be able to form a new bond through a collision. Reactants have a certain energy level, and the products are either at higher, endothermic, or lower, exothermic energy levels. The energy does not constantly decrease in a reaction process, but it has to go through an energy barrier. This energy barrier is called activation energy. When a successful collision happens, the old bonds are being broken and then the new bonds are being formed. The entity that is neither a reactant nor a product, therefore does not have completely broken old and newly formed bonds, is called the transition state or activation complex. Therefore, the activation energy is the energy required to form the transition state.